In this video, we're going to explore the interpretations of addition and subtraction. Now, when we talk about addition, we're talking about the sum of two numbers, A and B, representing the total number of objects that will begin with A objects and then get B more objects. Often we call A and B the add-ins or sum-ins, and sometimes we will also call them the terms. As a statement, you'll see this written as A plus B equals C, where C will be your sum. In subtraction, the difference of A minus B represents the total number of objects we will have if we begin with A objects and take away B of those. A we often call the minuend, and B is called the subtrahend. You can also use the generic terms as well. As a statement, you'll see the minuend minus the subtrahend equals the difference. And these subtraction statements, one nice thing to recognize is that they always will correspond with an equivalent addition statement, such that we know that the difference plus the subtrahend will always equal the minuend. Or we know that A minus B equals C, so A has to equal C plus B. As an example here, we know that if we do 8 minus 3, we get 5. But we also know that 5 plus 3 has to equal 8. Now, when we talk about addition and subtraction problems, we have four primary ways we can see them. They can be join, separate, part, whole, or comparison. And each of those can deal with different unknown items. For example, when we do the join of the change join problems, we have some action that occurs over time, and something's going to change. So when this happens, we can either have the result not known, where we began not known, or what's changing not known. And here's the three problems. So say Timmy had 32 cars, Sam gives him 12 more, and we want to know how many total cars does he have. And we'd represent that with the statement 32 plus 12 equals the result. Whereas in comparison, say that we don't know how many cars Timmy has. Sam gave him those 12, and we know he ended up with 44 total. So how many did he have originally? Now this is a little bit more difficult for students to recognize because you don't know where you began, and sometimes it's harder for them to work backwards. And then you can have a change that's unknown. We started with the 32 cars, we get a couple more cars, and we know we end up with 44. And we know how many were we given. And then we have our start plus whatever our change is equals 44. Each of these problems can pose different issues for students, and we have to recognize that they can have to think about them a little bit differently each time. The same occurs with the change separate problems, because it's still an action occurring over time where there's some change as well. In this one, again, it could be an unknown result, an unknown start, or an unknown change. For example, Andrea has 24 rabbits. She gives away 3 rabbits. How many does she have left? Maybe we just know she has some. We know how many she gave away with the 3, and we know that now she has 21, and we know how many did she originally have. Or you can even say that we know she has 24, we know that some of the rabbits were given away, and we will know now that she has 21 rabbits, and we want to figure out what was that change that she had. Just like the addition or the combined change, each of these poses different issues for our students, so we have to be considerate of that. With part, whole problems, we're involving some relationship between a set or two distinct sets. There will be no action and no change. And we could either not know what the whole is, or we may not know what one of the parts are. For example, I have 5 boys and 11 girls. How many are in my entire class? The whole class. So I set that up, 5 plus 11 equals the whole class. Whereas if I don't know one of the parts, I'd say I have 16 students, and I know 11 of those are girls, and the rest have to be boys. How many boys do I have? And it'd be 11 plus the part representing the boys equals my whole of 16. Now compare problems are probably some that really students struggle with quite a bit because you're looking at the relationships of quantities and we're comparing them. Often we can set them up saying what's our referent, what's being compared to that, and then what's the difference between the two. So if we don't know what the difference is, Corey has 12 crowns, Tammy has 7 crowns, how many more crowns did Corey have? And it's that how many more can really throw students off and they can struggle with that. Now maybe we don't know how many the referent is. In this case, Corey represents our referent. He's our starting place. But we know that Tammy had 7 crowns, Corey had 5 more. So there's that difference, the 5 more. And how many crowns does Corey have? And that can be a very big struggle for students because we know we have our referent, we're going to get, it's minus that compared component, and then it's left with the difference, the 5 more. And last one, if we didn't know the compared set, we know how many Corey has. We know Tammy has 5 fewer, and we know how many crowns does Tammy actually have. And we got the 12 minus the compared, which is Tammy, will equal the difference between the two. Now we have to be careful with our key words because they can change the context of a problem. For example, the comparison problems are especially an issue with this. As you can see, some of those could be difficult for students to represent. So say we had this problem though. Sandra has 4 balls, soccer balls, and you want to know how many more balls would be needed to have 9 balls altogether. Now those keywords are more and altogether, and oftentimes that triggers in students' heads to add. But what is the addition? Is it 4 plus 9, or is it 4 plus some change equals 9? And this is a very big issue for students to overcome. Because really what ends up happening is we're going to move that 4 over and say 9 minus 4 gives us that change, which is 5 total balls. Now one way we can deal with this is to draw it out either with diagrams or number lines. So say we have the same problem. What we know is we started with 4 balls, and we can represent that on a number line as well. And we want to know that in the end we want 9 soccer balls. So that would take us to 5 balls, 6 balls, 7 balls, 8 balls, 9 balls. We got to 9 balls, and now we can see, well, how many balls do we have to add? We had to add 5 more. Or you can see the yellow lines, there's 5 yellow lines, so that would be how many balls we have to add.